Welcome to another video of time value of money. In this video, we'll look at the case of present value of an uneven cash flow. As we had seen in an annuity, the cash flow is in the form of a series of equal payments or receipts. For example, in case of an annuity, the cash flow may look something like this. Let's say this is a time scale for 5 years, and you are going to get a payment of 2000 rupees at the end of each year. So as you can see, all these payments are equal. So this is the case of an annuity. However, the investments made by firms do not often yield constant periodic cash flows. In most of the cases, the firm receives a stream of uneven cash flows. For example, common stocks or shares. So a firm may have bought common stock or shares of another company as a form of investment. Now this company will be paying dividend on a regular basis. However, the amount of dividend is not constant and may vary over time. So an example of such a cash flow is something like this. So let's say this is again a time scale representing 5 years. Let's say at the end of first year you are getting 1000 rupees. At the end of second year you are getting 1500. At the end of third year 800. At the end of fourth year 1100. And at the end of fifth year 400 rupees. So this is the case of uneven cash flow. Now, as you have seen in the previous videos for annuities, we used the term PMT to denote the periodic equal cash flow. However, in case of uneven cash flows, we will use the term cash flow or CF. Let us consider an example to understand this concept better. Consider that an investor has an opportunity of receiving rupees 100, rupees 200, rupees 200 again, rupees 200 again, rupees 200 again, rupees 0 and rupees 1000 respectively at the end of 1 through 7 years. Find out the present value of this stream of uneven cash flows if the investor's required interest rate is 6%. So let us first represent this problem on a time scale. So this is 0, 1, 2, 3, 4, 5, 6 and 7. So total of 7 years. Now the first year, at the end of the year, the investor is receiving 100 rupees. At the end of second year, the investor is receiving 200. Third year again 200, fourth year again 200, fifth year again 200. At the end of sixth year 0 rupees, and at the end of seventh year 1000 rupees. The rate of interest that the investor is getting is 6%. So here we have to find out the present value of this stream of cash flow when the interest rate is 6%. So what is the present value? So let us look at multiple methods of solving this. So the first method is solving this using the formula for compounding or discounting. Now, this present value can be broken down into 7 different parts. Let's say this is PV1. Now, this PV1 should be such that at 6% interest, it can allow us to withdraw 100 rupees at the end of first year. Similarly, PV2 should be such that at the end of second year, it should allow us to withdraw 200 rupees at an interest of 6% per annum. And similarly, we'll have PV3, PV4, PV5, and so on up to PV7. Now the addition of all these present values should be equal to this present value here. So PV is equal to PV1 plus PV2 plus PV3 plus PV4 plus PV5 plus PV6 plus PV7. Now, this is the case of compounding, where the present value is getting converted into a future value at a certain rate of interest. So the formula for compound interest is A is equal to P into 1 plus R by 100 to the power n, or A is equal to P into 1 plus I to the power n. A is the amount of money that we are going to get at the end of the tenure. P is the amount of money or the principal which is being invested at the beginning of the tenure. I is the rate of interest per annum, and n is the number of compounding periods. So in case of PV1, first let's convert this into the future value and present value. So A can be written as future value. This is equal to present value into 1 plus I to the power n. So FV1 is equal to PV1 into 1 plus I to the power n1. I'm putting n1 because every single cash flow will have a different tenure. So PV1 is equal to FV1 divided by 1 plus I to the power n1. So let's write this formula here. So FV1 divided by 1 plus I to the power n1 plus FV2 divided by 1 plus I to the power n2. And similarly for the remaining. So let me write this up. So now let's substitute the values here. So FV1 is 100, FV2 is 200, and so on. So 100 divided by 1 plus I is 0.06. So this becomes 1.06. So 1.06. And in case of PV1, n1 is 1, so raised to the power 1, plus FV2 is 200 divided by 1.06, and in case of PV2, n2 is 2 years, so square, plus 200 divided by 1.06 cube plus 200 divided by 1.06 to the power 4 plus 200 divided by 1.06 to the power 5 plus 0 divided by 1.06 to the power 6 plus 1000 divided by 1.06 to the power 7. So these are the calculations, and the total comes out to be 1413.19 rupees. So basically the present value of this uneven cash flow is 1413.19 rupees. Now let us look at another method of solving this example. The second method is to use the formula for present value of an ordinary annuity. Now if you take a closer look at the time scale for this example, you will find that for years 2, 3, 4 and 5, the payment amount is a constant sum, which is 200 rupees. So the cash flows between periods 2 and 5 represent an annuity. So we can use this fact to solve the problem slightly differently. So what we can do is we can take these 4 and use the formula of present value of an annuity to find the value at this point. So the present value of an ordinary annuity formula will get us the value at this point. From here, we can then discount it to get the value at the starting of the tenure. Then we can take the value of this 100 rupees, get the discounted value, and then also do the same thing for 0 and 1000. So this total here will give us the present value. So if we break this time scale from the beginning of second year to the end of fifth year, basically you can represent it like this. So let's say the end of first year is 0, then 1, 2, 3 and 4. So this 1 is representing this 2 here, this 2 is representing this 3, 3 is representing this 4 and so on. Now at the end of each year the cash flow is 200, 200 and 200. The rate of interest is 6%. We have to find out what is the present value. So the formula for an ordinary annuity is PV is equal to A into bracket 1 divided by I minus 1 divided by I into 1 plus I to the power n, or PV is equal to, now the annuity amount here is 200, I is 6%, so 1 divided by 0.06 minus 1 divided by 0.06 into 1 plus I is 1.06, and n here will be 1, 2, 3 and 4. So this value comes out to be 693.02 rupees. So this value is at this point here. But in order to get to this point, that is at the beginning of the first year, this amount has to be discounted at 6%. So right now we have 4 components of this present value. The first component is the one which is going to give us 100 rupees at the end of first year. The second component is going to give us 693.02 rupees at the end of the first year. The third component will give us 0 rupees at the end of the 6th year, and the fourth component will give us 1000 rupees at the end of the 7th year. So basically PV now is equal to PV1 plus PV2 plus PV3 6 plus PV 7. I'm considering 2 as the PV for this whole portion. Or PV is equal to, now PV1 will be FV1 divided by 1 plus I to the power n, plus PV2 will be FV2 divided by 1 plus I to the power n. PV6 is FV6 divided by 1 plus I to the power n, plus FV7 divided by 1 plus I to the power n. Now actually this n here is going to be different for each of these. So for the first one, the tenure is 1 year, so this is n1. For second, again we have the value as of this point, which is 1 year from the start of the tenure. So this again is going to be n1. For FV6, it's going to be 6 years, so I'll say n6. And for FV7, this is n7. So let's plug in the values here. FV1 is 100, so 100 divided by, now I is 6%, so this becomes 1.06. N1 is 1, so this will be as is. FV2 is 693.02 divided by 1 plus 0.06, which is 1.06, and N1 again 1 year, so this will be as is, plus FV6 is 0, so 0 divided by anything will remain 0, so I'll leave it as it is, plus FV7 is 1000 divided by 1.06 to the power 7. So this is equal to 94.34 plus 653.79 plus 665.06, and this will come out to be 1413.19 rupees, which is the same answer that we got in the first method. So this can come in handy when you have a lot of years with the same equal cash flow, and you can use the formula for annuity. Now let us look at the third method, which is to use the present value factor. The third method is to use the present value factor of a lump sum. Note that this is present value factor of a lump sum and not for an annuity. We can't use the present value factor table of an annuity because we have an uneven cash flow. However, we can use the present value factor of a lump sum, considering that each of these cash flows is a independent lump sum amount which we are receiving at a future point in time. So from here to here this is 1, from here to here this is second, from here to here this is third, and so on. So each of these can be considered as a lump sum amount with varying value of present and future values and the tenure. So as we had seen in method 1, basically the initial amounts will be PV1, PV2, PV3 and so on. So basically PV, that is the total present value, is equal to PV1 plus PV2 plus PV3 plus PV4 plus PV5 plus PV6 plus PV7. Now each of these PVs is found out by using the formula FV divided by 1 plus I to the power n. This can also be written as FV into 1 divided by 1 plus I to the power n. And as we already know, this part is also known as the present value factor of a lump sum. So this is equal to FV1 into present value factor, where for PV1 n will be equal to 1 and I will be equal to 0.06. So this is the value for PV1, plus for PV2 FV2 into present value factor, where n is equal to 2 and I is equal to 0.06, and so on. Plus for PV7 it will be FV7 into present value factor, where n is equal to 7 and I is equal to 0.06. So now let us look at the table for present value factor of a lump sum to find these values. So as shown on the screen, this is the present value factor table of a lump sum of rupee 1. So here we can see these periods and the rate of interest. In our case, the rate of interest is 6%, so this one. And we have periods from 1 through 7. So basically our values are all of these till this point here. So let us use these values in the formula. So this is equal to, for PV1, FV1 is 100 and the value of PVF was 0.9434, plus for PV2 the value of FV2 was 200 into 0.8900 plus, so let me note down all these values. So these are all the values. Now let's calculate this. So 100 into 0.9434 plus 200 into 0.8900 plus 200 into 0.8396 plus 200 into 0.7921 plus 200 into 0.7473 plus 0 into 0.7050 plus 1000 into 0.6651. So the answer is 1413.24 rupees. Now in the first and second method, the answer we got was 1413.19 rupees. So pretty close, because here we are rounding off to 4 decimals. So there may be differences in the rounding off for decimal points, but this is pretty close. Now this method is also not very short, because you have to find out the present value factor for each cash flow and then calculate the entire thing. However, depending on the preferences, some people may find this easier because it is simple to calculate as compared to the first method, where we had little complicated calculations because we had exponential values and 1 by x and so on. Now let's look at the fourth method, which is to use the financial calculator. Now while using a financial calculator, you first input the individual cash flows in chronological order into the cash flow register. Cash flows are usually designated as CF0, CF1, CF2 and so on. So the CF0 is the cash flow at this point here. CF1 is the cash flow at this point. CF2 is the cash flow at this point. So let's note down CF3, CF4, CF5, CF6 and CF7. So in our case, CF0 is 0 because at this point there is no cash flow at the beginning of the tenure. CF1 is 100, CF2 is 200, CF3 is 200, CF4 is 200, CF5 is 200, CF6 is 0 and CF7 is 1000. So once we have entered the cash flow amount, then we have to enter the interest rate, which is I, and in our case it is 6%. And then we have to press the net present value. Net present value, because the cash flows could be positive or negative. So this NPV or net present value gives us the net value of the cash flow at the beginning of the tenure. So let us look at the financial calculator. So let us locate the CF0, which is here, CF0, and then CFJ is here. So CF0 is this here, and CF1, 2, 3, 4, and so on will be CFJ. Now the method to enter numbers or enter data into the financial calculator is that first we enter the value and then let the calculator know what that value stands for. Now the cash flow we have to enter in a chronological order. So first we'll enter CF0. So 0, and then we have to enable the blue button here. So G enables blue buttons, and then CF0. Then CF1 is 100. So 100, and then blue button and CFJ. Next is 200, blue button and CFJ. Again 200, and then CFJ. Again 200, CFJ, 200, CFJ. The next cash flow amount is 0, G, and then CFJ, and the last one is 1000, G, and then CFJ. So we have now entered all the cash flow amounts in the chronological order. Now we have to let the calculator know the rate of interest, which is 6%. So 6, and then I. And now we have to calculate the net present value. So you can see the NPV button here. To enable this, we have to click on this button F, and then we'll click on the PV button. So the net present value comes out to 1413.19 rupees. So this is in line with the other methods that we had used. So you can use any of these 4 methods to find out the present value of an uneven cash flow.